let us see one problem regarding orthographic projections. So basically in orthographic projections, we have given one 3D object with dimensions and we have to convert that 3D into 2D projections like front view, top view, side views like this. So our data is like this. For the cuboid 50 mm by 30 mm and 20 mm, draw all 6 orthographic views using first angle projection method. So your object is cuboid in which length of the object is 50 mm, 30 mm width and 20 mm height. So this is known as length of the object, width of the object and height of the object. So this is 3D pictorial view. The arrow represents the position for front view. So when we observe from here, we look the front view of the object. When we observe from here, this is a left hand side view. And when we observe from top, this is the position for observe. Now how to start your problem for any orthographic projections? First of all, we have to find out the overall length, width and height. It's 50, 30 and 20. So front view is always represents the length of the object and height of the object. Because we are using first angle projection method, our front view is located above XY line. Now top view, so when we observe from top, we will get two dimensions, length and width. That time the height is hidden. When we observe from front, we can see length and height, but what about width? We cannot see the width of the object. So front view represents two dimensions only, length and height. Similarly from top, the green surface which is length and width. So this is top view. This dimension represents length of the object and this dimension is width. So which dimension is common for front and top view? Obviously length. So length of the front view and length of the top view are always equal. Now once you draw the front view and top view, how can we find the side view? So for that, we have to take a 45-degree inclined line from the intersection of xy and x1 y1 from this point and take the horizontal lines from top view up to this 45 degree. Now you have to project or draw horizontal line from every corner from top view. Then draw the vertical lines. These are known as projection lines. And from front view, draw horizontal lines. The intersecting points which represents the side view. So from left hand side view, this rectangle which represents width 30 mm and height 20 mm. So this is 30 mm width and 20 mm height. So when you looking from left hand side, you cannot see the length. For front view, you cannot see the width, and from top view, you cannot see the height. So any 2D projection represents only two dimensions. So this is position for front view, top view, and left hand side. Now what about remaining views? Now bottom view is always above front view. So for bottom view, you have to draw again one reference line parallel to xy and 45 degree from intersection of xy and x1 y1. Project vertical up to 45 degree, then horizontal and vertical from front view. So this is bottom view. Another reference x1 y1 line 45 degree, extend from bottom view and draw the right hand side. So in first angle projection method, left hand side view is always right of the front view and right hand side view always left of the front. And last, when we observe from back side means rear, the rear view is same as front view, but it is placed here on right of the left hand side. So these are the number of views, but in our practice we have to draw maximum 4 view, front view, top view, left hand side view or right hand side view for remaining problems. So these are the dimensions: 50 mm length, 30 mm width and 20 mm height. Now if you insert one dimension for length here, so there is no need to insert another dimensions for length in front view or bottom view. One dimensions 20 mm for all this view, and here the width is 30 mm, so there is no need to insert here for left hand side with 30 mm. Okay, so you have to consider this important points also. Okay, thank you very much for watching this video.